Welcome to section 6.4, application, consumer and producer surplus. So first we're going to do a little bit of a warm-up and recall that an equilibrium point is when the supply and demand curves intersect. Okay, so we're going to do a little example with that. If we're given the supply as P is equal to 3 plus Q squared, and the demand is P is equal to 21 minus Q squared, we want to find the equilibrium point. All right, so all we need to do is set the supply and demand curves equal to each other to find where do they intersect. So we have 3 plus Q squared is equal to 21 minus Q squared. We'll add the negative Q squared to both sides, so we get 3 plus 2Q squared is equal to 21. Subtract a 3 over, so we have 18, and then divide by 2, so Q squared is equal to 9. If we take the square root, we get Q is equal to positive or negative 3, but having a negative quantity doesn't make sense, so we choose Q is equal to positive 3, again because a negative quantity does not make sense in our context. All right, but so here we found the equilibrium point occurs at 3 for the quantity, and then we could plug this in to find out our equilibrium price as well if we wanted to. So let's go ahead and jump into a definition. So the consumer surplus, these are a little bit of a lengthy definition here, all right, measures the consumer's gain from trade, all right, it is the total amount gained by the consumer by buying the item at the current price instead of the price they would have been willing to pay. All right, and then we have the producer surplus, and we're going to dive into what these definitions actually represent in a second. So then we have the producer surplus. All right, so this measures the producer's gain from trade. All right, it is the total amount gained by the producer by selling at the current price instead of the price they would have been willing to sell at. Okay, so let's go ahead and look at some graphs to see what are we actually talking about here. All right, so if we look at a graph of a supply and demand, okay, we have our equilibrium point right here. It's where they intersect. And on our demand curve, this is the price that consumers would have been willing to pay. So this is the highest price possible that they would have been willing to pay, right? And on the supply, this is the lowest price that the producer would have been willing to sell at. Okay? So neither one of them, so the producer is not selling at the lowest price possible, and the consumer is not buying at the highest price possible. Instead, they decided to meet in the middle, and they're selling at the equilibrium price, or you should be selling at the equilibrium price, because we have this thing called consumer and producer surplus. So this shaded region on our first graph is our consumer surplus. And so this represents the amount of money that the consumer is going to gain or get back by being willing or by being able to buy the product at a lower price. At the same time, the producer also benefits. So the idea is that both the consumer and the producer are making money by compromising and meeting in the middle, or meeting at the equilibrium point. All right, so our consumer surplus is the area between the demand curve and the horizontal line at this graph here uses P star to label the equilibrium point on the price axis. Okay, and our producer surplus is the area between the horizontal line at P star and the supply curve. All right. And if you recognize this wording, we sure can use integrals to calculate the area between these curves. And so we can find the total consumer surplus and producer surplus in that way. So let's go ahead and look at example 1, where it looks like my thing got a little bit squished. There we go. All right, so we're given this graph of the supply and demand curves for some sort of product. All right, part A asks, what are the equilibrium price and quantity? Well, this dot here right in the middle is our equilibrium point. Okay, and so it looks like our equilibrium quantity is 80,000 and our price is $80 per unit. So 80,000 units and $80 per unit. Okay? And part B asks us to find the consumer and producer surplus. All right? So our consumer surplus, let's go ahead and take a look at our graph. I'm going to draw some dotted lines here. All right, to our equilibrium point. And our consumer surplus is the area between our horizontal line at our equilibrium point and the demand curve. So this area here. Well, we have a triangle. So we can use the area of a triangle to calculate this. All right, so I'm going to zoom out a little bit. So our consumer surplus is going to be the area of this top triangle. I'll say the red triangle. How about that? Area of the red triangle. Okay, which we know the area of a triangle is 1/2 the base times the height. So our base is 80,000. All right. And our height is going to be the top price, our 240, minus the 80. All right, so that will give us 160. Right, so that was our 240 minus 80, gave us our 160. So that's our base times our height. We take 1/2 of that, we get the area of our consumer surplus triangle, which ends up being 6,400,000. Okay, so we were also asked to interpret this. So what does the consumer surplus mean? So this tells us that consumers, and obviously it's not a singular consumer is not gaining $6 million, right? It's consumers as a whole. So consumers gain this $6,400,000 in buying goods, by buying goods at the equilibrium price. Instead of at the highest price they would pay. So essentially they are saving money, not really gaining, but saving. Okay. And let's look at the producer surplus. So again, this is going to be the area of this triangle. All right. So we need the area of our blue triangle, which is going to be 1/2 our base, which is the same base, it's 80,000, times our height, and this time the height is 80. This is our total height here. All right, so 80,000 times 80, 1/2 of that, and we get 3,200,000. And our interpretation is producers gain 3,200,000 by supplying the goods at the equilibrium price. Price. Instead of at the lowest price. All right, let's do another one. So example 2 is down here somewhere. We go, example 2, we want to find the producer surplus for a supply curve. All right, when P is equal to 28 is the equilibrium price. So we don't have a graph, all right, so we can't say if it's the area of a triangle or a circle or whatever. Instead, we need to use our integrals, and we need to use the area between two curves. Even if it's a straight line, we can call it a curve. All right, so we have our function. Let's say this is 28. And our supply curve looks like it's going to be an upwards facing parabola starting at 10 and going like this. All right, rough sketch. So P is equal to 28 comes out to here. And they intersect at our equilibrium point. Okay, so our producer surplus is the area between our supply curve, which is this one, supply curve, and our horizontal line at the equilibrium point. So from this graph that we have, we can see that our horizontal line is our top function. So when we need to find the producer surplus, it's going to be the integral, all right, of our top function, which is just 28, minus our bottom function, which is 10 plus 2q squared, dq. The next thing we need are limits of integration for our integral. All right, and so we need to find the equilibrium point, or where they intersect. So we need to find our equilibrium quantity. We have the equilibrium price, but we need to find the equilibrium quantity because we need our integration bounds to be with respect to q. All right, so if we have p is equal to 10 plus 2q squared, we need to find q when p is 28, because we were given that the equilibrium price is 28. So now we just need to solve for q, so we'll subtract 10, and we'll get 18 is equal to 2q squared, divided by 2 will give us 9 is equal to q squared. And so then we get q is equal to, again we have positive or negative 3. We're going to choose positive because negative in a quantity does not make sense. All right, so q is equal to 3, and this is our equilibrium quantity. All right, so that's going to be our top bound, and our bottom bound is going to be at 0 because we don't have anything on the other side of 0. All right, it doesn't make sense, again, to have negative quantity or negative price. So we want this total area starting at 0 going up to 3. So we just need to take this integral. Well, let's go ahead and simplify the inside first. So we have the integral from 0 up to 3. 28 minus 10, well, that's 18 plus 2q squared with respect to q. All right, and so by going through and taking the integral of each piece, we have 18q plus 2/3 q cubed. And then all of this needs to be evaluated from 0 to 3. All right, so we get 18 times 3 plus 2/3 3 cubed minus 18 times 0 plus 2/3 0 cubed. So everything over here is going to come to 0. And on the left-hand side, we get 54 plus 18, so we get 72 as our final answer. So our producer surplus is the area between two curves, so we have 72 area units. All right. Example 3, we want to find the consumer surplus and the producer surplus given the following information. So we're given a supply and a demand curve. So the first thing we need to do is set them equal to each other and find the equilibrium point. All right, so we have 400 minus 8q is equal to 15 plus 5q. And so we subtract 15 and then we add 8q. We get 385 is equal to 13q. Divide both sides by 13 and we get that 29.6 is the equilibrium quantity. All right. So we have our supply and demand. This is our supply. This is our demand. This is our supply. We've found that our equilibrium quantity is at 29.6. Okay. So we need to determine, again, this is our equilibrium price over here. All right, so for our consumer surplus, well, this is the integral from 0, starting at 0, all the way up to our equilibrium quantity, 29.6, of we need to find the top function minus the bottom function. All right, so our top function is our demand function. So we need 400 minus 8q minus our bottom function, which is our equilibrium price. So we need to find that really quickly. We can go ahead and take our equilibrium quantity and plug it into either the supply or demand curves. Either one would work. But if we plug it into the demand curve, we get P is equal to 400 minus 8 times 29.6. And so we get our equilibrium price is 163.2. So our top function was our demand, and our bottom function is our horizontal line at our price, which is 163.2 dq. Then we need to go ahead inside and simplify our integral. So 400 minus 163.2 gives us 236.8, and then minus 8q dq. Go through and take this integral. So we have 236.8 times q minus q squared over 2 times 8. So this just comes to 4q squared, evaluated from 0 up to 29.6. All right, so we have 236.8 times 29.6 minus 4 times 29.6 squared, minus, and everything on the right hand is just going to be 0. And so plugging this into a calculator, we get 3,504.64. So that is our consumer surplus. All right, but now we need to find the producer surplus. So our producer surplus is similar. We go from 0 up to our equilibrium quantity. But the thing that's different is our top and bottom functions. So in this case, we're between the horizontal line and the supply curve. So our horizontal line is actually our top function. So we're going to start with 163.2 and then subtract our bottom function, which is our supply curve. So 15 plus 5q with respect to q. So then we can go through and simplify inside of our integral. So we get 148.2 minus 5q dq. So we get 148.2 times q minus 5 halves q squared, evaluated from 0 up to 29.6. So we get 148.2 times 29.6 minus 5 halves times 29.6 squared. Everything else would evaluate to 0, and we get 2,196.32 as our producer surplus. So for this problem, our consumer surplus ended up being greater than our producer surplus. So let's look at example 4. A company called Golf Today, a producer of golf balls, has determined that the supply function for the new golf ball is given by this function here, where Q is the number of dozens supplied each month and S of X is the price per dozen. If the equilibrium price is $19.30 per dozen, determine the equilibrium quantity and then find the producer surplus. All right, so our price, S of x, is given by 0.24 times our quantity plus 3.70, and we are given our equilibrium price. So we're given the price is $19.30. So we can go ahead and say, well, the price has to be equal to $19.30. So when it's equal to that much, what is the quantity? So here we could just go ahead and solve for Q. So if we subtract 3.70 from both sides and then divide by 0.24, we'll get Q is equal to 65. So this is our equilibrium quantity. Okay? And the next thing we're asked to find is the producer surplus. So our producer surplus, our bounds need to be for Q, so from 0 up to 65 of, in our producer surplus, our top function is our horizontal line. So our horizontal line is our price, which is $19.30, minus our supply function, which was given as 0.24 Q plus 3.70, and parentheses with respect to Q. All right, so let's go ahead and simplify inside of our integral. We end up with 15.6 minus 0.24 Q. All right, so we get 15.6 Q minus 0.24 Q squared, but then divided by 2, evaluate that from 0 to 65, and eventually we will end up with 507. So 507 is our producer surplus. So example 5 asks us to sketch a possible graph for supply and demand curves given two different situations. So for A, we have a producer surplus that is greater than the consumer surplus. All right, so the producer surplus is the one that is underneath of our horizontal line. All right, so let's say we draw our demand function. Our demand function is like so. And we need to draw a supply function that gives us an equilibrium point where our area underneath of our equilibrium price is larger than our area above. So I'm going to draw one that should give us an equal amount here. This is our supply. So then this would be our equilibrium, okay? And our producer surplus is what's down here, underneath of our horizontal line. So we want to make that bigger than the area above our horizontal line. All right? So I'm going to take our supply function and draw it much steeper, something like this. This is now our supply function. So our horizontal line over to our equilibrium point is all the way up here. Therefore, our producer surplus is a much larger area than our consumer surplus. All right. Let's think of it in a similar manner for part B, where we have a consumer surplus, which is the area above our equilibrium line, is greater than our producer surplus. So if we draw the same demand line, okay, we need to think of a supply that makes our consumer surplus larger. So we can do a much shallower line, a much flatter line, something like this. Pretend it's straight, okay? So this is supply. And so our equilibrium line is somewhere like that. And our consumer surplus is all of this area, which is much larger than our producer surplus here. And these are both just examples. There are several different supply and demand curves that could work for this. All right, this is just one instance. All right, let's look at example 6. So suppose a company's supply equation is given by this function here, and demand is given by this function. We need to find the equilibrium price and quantity. Okay. So we know that this happens when the two functions equal each other, when they intersect. So we can go ahead, set them equal to each other, and solve. So we have the square root of p minus 5 is equal to the square root of negative 1/2 p plus 16. We can go ahead and square both sides to get rid of that square root. So we have p minus 5 is equal to 1/2 p plus 16. Go ahead and add 5 to both sides, and then add the 1/2 p to both sides, and we get 1½ p is equal to 19. Then we can divide by 1.5 to get p is equal to 12.66. And this is our equilibrium price. And so to find our equilibrium quantity, we just need to plug p into one of our equations, either the supply or demand equation. So we have Q is equal to the square root of 12.66 minus 5. So we get Q is equal to 2.77. So this is our equilibrium quantity. All right, so we found our equilibrium price and quantity. Now we need to find the consumer surplus. And we have a little bit of an issue with our supply and demand functions. All right, they were given to us as Q equals. Okay, so they're in terms of P. So both supply and demand curves or functions are in terms of P. So if we tried to take the integral with respect to Q, we would not be able to, right? There would be no Q values in there. So we cannot take the integral with respect to Q. So a way that we can fix this is to rearrange the functions so that they're in P equals form and in terms of Q. We need to rearrange the functions. So if we take, I need a lot more space. So if we take Q is equal to our square root of P minus 5, we just need to solve for P. So we're going to go ahead and square both sides to get Q squared is equal to P minus 5. Add 5 over, and we get P is equal to Q squared plus 5. So we have a new supply function. This is our supply function. Okay? And we'll do the same thing for our demand function. We'll take Q is equal to the square root of negative 1/2 P plus 16. We'll go ahead and square both sides. So we get rid of that square root. There we go. Negative 1/2 P plus 16. We'll move some things around. So we get Q squared minus 16 is negative 1/2 P. Go ahead and multiply by a negative 2. So we get negative 2Q squared plus 32 is equal to P. And this is our new demand function. So now that we have our equations in P equals form, so in terms of Q, we can go about finding our consumer surplus. So our consumer surplus is our integral for our Q bounds, so starting at 0, going up to our equilibrium quantity, which is 2.77. All right. And our consumer surplus is the area above the horizontal line. So our demand equation is first, so we have negative 2Q squared plus 32. And then subtract our bottom function, which is our horizontal line at 12.66. And then with respect to Q. So we have to make sure there's no P's anywhere inside our integral, only Q's. All right, so our consumer surplus, if we simplify a little bit inside of our integral, we get 29.23 minus 2Q squared dq. And I'm going to go ahead and just tell you that this is equal to 66.79. So that is our consumer surplus. And then our producer surplus is our integral, still from 0 up to 2.77, but it's the area under our horizontal line, so we start at 12.66, and then we go to our supply function, which is our Q squared plus 5 dq. And if we clean this up inside, 0 up to 2.77, we get 7.66 minus Q squared dq, which will turn out to be 14.13. And that is our producer surplus. So that wraps up chapter 6.4. Don't forget to take the comprehension quiz. If you have any questions, please shoot me an email, and I'll see you again in our last lecture.